Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of solutions for systems of equations. This is standard A.3F in the great state of Texas, and we are using item number 3 of the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So, which graph best represents a system of equations that has no solution? All right, so let's pretend we don't know what that means. What can we tell from our 4 answer choices here? Well, we notice that each of the coordinate grids here has 2 different lines on them. Now, they're doing different things, but we see 2 lines on each of these. So, system of equations. Right, so what can we infer from that? Well, what we have is we've got 2 functions on the same graph. All right, so each of these functions here are linear equations and they're displayed on the same graph. So we're looking for one that has no solution. Well, first off, what is a solution? Well, when we're graphing straight lines, right, each of these lines is going to have something, right, in our slope-intercept form or standard form. But if we were to do slope-intercept, right, what would that look like if we were to try to take the 2 different lines, let's say on A, right? So A, I don't know what the y-intercept is, but I can see we've got, x-intercepts of one line of -4. I've got another line of -6. If I could find some other points that cross on integers, we might be able to find it, right? But it's going to end up being something in this form right here, y equals mx plus b. And then the other one's going to be slightly different. So our solution here most likely is going to be this. The only thing that makes sense, assuming we don't know what that already means, it's where it intersects. Okay? So the solution, if we are graphing it, is where 2 lines intersect. All right, so whatever this point is, and we're really not quite sure. It looks like it's not an integer, -4.2 and maybe 3.1. It's some type of decimal. But if we were to find the slope-intercept form of both of those and then plug in the x value and the y value to both of these equations, whatever this intersection point is, then it would make true statements. That's what a solution is for an equation, is when you can find any point that's on the graph, plug in the x and the y, and it becomes a true statement, like 8 equals 8 or -5 equals -5. Well, then a solution would be one point that works for both graphs. That's why it's the intersection. Okay, so it's not A, because A has a solution. Now B, well, we'll get back to B. C, that looks like it's pretty easy. Our solution is the origin, right? They look like it's direct variation, so they look like it's y equals kx. There's no y-intercept, so my solution is right there, 0, 0. So it's not that. So I'm stuck between B and D. There's no visible solution for either. But take a look at B. B just happens to not have a big enough graph. If I were just to extend this line out here, and I were to extend this line right here, somewhere off the graph, really close to the x-axis, maybe a little bit above, you see they will eventually intersect, which means there will be a solution for these 2 lines. The one that's got no solution is going to be D. Let's take a look. Same distance apart. So visually, it's really easy to see. When you have parallel lines, you have no solution. So our answer is D.